Okay, so let's go over some of these data pre-processing steps so that you can set up your own artificial neural network in your assignment. So once again, we're working with this home price data set. Okay, and this is, in fact, this is just all of the same code that we looked at on Tuesday. The only difference is we sort of breezed over this code on Tuesday. In this class, I'm just going to talk about what these lines do. Okay, so we read in the data, number one. Okay, and number two, we convert the categorical variables into factors. Okay, recall that the categorical variables in this home price data set, right, are things like for example, whether the heating is electric or based on steam, or whether the fuel used by the home to heat the home is electric or gas or oil or whatever it is. Okay, it's some of these text-based variables. And for a lot of different packages in R, before we can feed in these variables into our model, we have to convert them into factors. So that's what I did here. For this set of variables, heating, fuel, sewer, waterfront, etc., we're simply going to convert those variables into factors. Okay, so now unfortunately, like I said, the neural networks, the artificial neural networks, they're very finicky about what kinds of data they can accept. And in this case, even a factor variable is not allowed. What we have to do is we have to take these factor variables and we actually have to convert them into a set of dummy variables. Okay, so how does that work? So let me explain that to you. Okay, so I'm going to run this next command. Okay, and this next command is simply, oh, I duplicated fuel here for some reason, my bad. This next command is simply basically a list of all of the different values in our data set. Okay, and I've passed this giant list of independent variables to a function called model.matrix. Okay, and this model.matrix basically accepts the names of all of the variables that I'm about to use in my model. I target this function. I tell it the data I want it to consider is called home price. Okay, and then I'm actually going to assign the value of this whole thing to temp. Okay, because this is basically, we're going to take this, we're going to scale it, we're going to do some other transformations to it, and then we'll have the final version. So I'm calling this temp. Okay, so let's see what this thing actually does. So I'm going to run this line of code. Okay, and I'm going to look at my temp data set, and we're going to compare this temp data set to my original home price data set. Okay, so you can see that, okay, if I look at this temp data set, you can see that, for example, the first value of the price here, okay, is 120,000 something. That's exactly what it was in my original data set. Okay, that's because price is a continuous variable. It's not going to be affected by this model.matrix function. Okay. However, if I look at heating, or actually let's look at fuel, okay, so this fuel variable in my original data has three possible values: electric, gas, and oil. Okay. If I look over here at this temp data frame, you can see that what it's done, okay, is that it's created a bunch of dependent variables. Okay, in fact, it's created two independent variables, which are dummy variables on the basis of that categorical variable. Okay, so you can see here I have fuel gas, okay, indicating a 0 if the home is fueled using gas, and fuel oil, again, indicating a 0 if, this thing is going to be a 1, okay, if the fuel is gas, and this other variable, fuel oil, is going to be a 1 if the fuel is oil. Okay, so what I'm trying to say is in our original data set, right, you can see that the first home was heated using electric heat. Okay, so that means once I convert this into dummy variables, this is going to be a 0 for fuel gas and a 0 for fuel oil. Okay, now notice there's no option for fuel electric. It's just understood that since there's three possibilities, if it's not fueled using gas and if it's not fueled using oil, then it's got to be fueled using electricity. That's the way all dummy variables work. Okay, if there are three categories, you're only going to have two dummies. But if that dummy is if the value of both of those dummies is a 0, then it's going to be implied that you're in the third category. Okay, so let's look at this next one. For example, this next house, house number 2, is fueled using gas heat. Okay, and so if I look at this temp data frame, you can see that fuel gas is a 1 and fuel oil is a 0. Okay, so in other words, we've taken our factor variables in our original data set now, and we've basically converted them into a series of dummy variables, okay, which sort of encapsulate the value of that original factor variable. Okay. Same thing, I'll just give one more example. Okay, so for example, you can see here is waterfront. Okay, in our original data set, we had this value, we had this variable called waterfront that was yes or no based on whether or not you're on the waterfront. In our new data set, you can see I have this waterfront yes variable. Okay, and if your house was on the waterfront, then this is going to be a 1 here, and if your house was not on the waterfront, then this variable is going to take on the value 0. Okay. So that's what this line of code here does. Okay, and when you are using this code, okay, all you have to do is in here you just need to put the names of all of the variables that are gonna eventually wind up in your model. Okay, and then this function, it's smart enough. It knows not to touch the continuous variables, but any variable that up here you've converted into a factor, it's going to convert that factor into a series of dummy variables. Okay. Okay. So then step number 3, and this is a very important step, is that we're going to scale all of these independent variables. Okay. And the way this scaling works is we're basically going to express each variable as a percentage of the maximum of that variable. Okay, so let's just do an example. Okay, so suppose that we were looking at the data for the heights of different people in our class. Okay. And what I would want to do is I want to scale the heights of everybody in our class to be between 0 and 1. Okay, so this is how it works. Okay, let's say that the highest person in our class is 6 feet. And let's say that the shortest person in our class is 5 feet. Okay, in that case, if you're the person who is 6 feet tall, your height will be scaled down to 1. Okay, so your height in the new version of the data would just be 1. Okay, if you're the shortest person in the class, if you're the person who's exactly 5 feet, then your new height, your scaled height, is going to be 0. Okay, and then for anything in between, you just you pick the appropriate value in between. So say you were 5.5 feet tall. In that case, your new value for height would be right in between 0 and 1, because you're right in between the minimum and maximum height in the class. Your new height would be 0.5. Okay, so that's what these next 4 lines of code do. Okay, well, actually, so this first line here, this first line is just for convenience. Okay, when you run this model.matrix command, it always creates an intercept variable. You can see it always creates this intercept variable and sets it equal to 1. We don't need this variable, so we're going to just drop it. Okay, so you can see here temp equals temp. This line here simply drops the intercept variable. It drops the first column, okay, from our data. Okay, and then these next 2 lines, they store the maximum and minimum values of each variable in our data set. Okay, so in other words, let me just run this line. Okay, maxes. Okay, so I'm going to run this line, and then let me show you what this max's value actually is. If I evaluate maxes, you can see that it basically just gives me the maximum value of all the variables in our data set, right? So here is the maximum value of price. Here's the maximum value of lot size, the maximum age. Wow, there's a 225-year-old house in our data set, apparently. Okay, so this max's variable simply is just going to store the maximum value of every single variable. Same thing with this one. This mins is going to store the minimum value of every single variable. Okay, and then this command here, okay, home price prepped, sorry, this should be an equal sign. Okay, home price prepped is going to be, so I'm calling this function scale. Okay, and I'm telling the function scale, okay, I want you to scale my data set. My data set is called temp. Okay, and then there are two parameters here. I want the center to be mins, and I want the scale to be maxes minus mins. If I set up this command the way that I've set it up here, then every single value is going to be scaled between 0 and 1 in the manner that I described. Okay, and this as.data.table command, you see, by default, this scale function is going to return a matrix. Okay, and then we simply need to convert that matrix to a data table, and so I have this as.datatable command. Okay, so now here's the thing. You might go, okay, well, this is a lot of new code. Okay, but you can just reuse this code when you're working with your own data. Okay, so you don't need to do all of this over again. You don't need to set this up yourself. This code will work, okay, with any data set. Okay, so all right, so let me just run those lines of code, and I'll show you what the prepped data set looks like. Okay, and so you can see here, okay, it looks kind of similar to before, but look what happened. Every single value in our new data set is now between 0 and 1. Okay, and so for example, the price of this first home, whereas before it was in the hundreds of thousands, now the price of this home is basically just 0.165, indicating that the value of this home is basically 16.5% of the most expensive home in our entire data set. Okay, and then notice, well, with these dummy variables are 0 and 1 anyway, so they don't, that scaling them into 0 and 1 doesn't do anything. These dummy variables are still what they were before, but we now have dummy variables, whereas before we had those factor variables that said, like, that said fuel is oil or fuel is gas or whatever. Okay. Okay, and then there's just one more thing we need to do, okay, which is that, so this neural network command that we're going to use, or this neural network package, it's a little bit finicky about what the variable names can be, okay? So you can see that originally, okay, before I run these commands, we have some unusual non-alphanumeric characters in our variable name, okay? For example, this variable is called heating hot water / steam. Okay, and that's only because in our original data set, we had this entry here called hot water - steam. Okay, well, there can't be any dashes in the variable name. Otherwise, our command is going to crash. Okay, our neural network training command is going to crash. So these next two lines, what they do is they simply replace all spaces in the variable names with underscores, and they replace all dashes with underscores as well. So any kind of weird character, okay, is going to just get replaced by an underscore. Okay, so once we run this set of commands here, okay, the commands that I have selected here, that's going to do all of the data prep that we need in order to begin using the neural network. Okay, so then just as before, we're going to split the whole sample into a test and a training set. This code is exactly the same code we've been using for the whole class. Okay, we're going to remove the recall that this process creates a variable called split in your data, which is either true or false based on whether it's going to put that observation in the training set or the test set. Okay, once we use that split variable to create the data to split the set, then there's no longer any need to have that split variable anymore. Okay, so we end up dropping it. So what I mean is, you can see if I run this and I look inside my training set, let's say, okay, you can see that, okay, so we have this split variable here and it's equal to true because, well, these are the ones that went into the training set. Okay, I don't need that split variable anymore after I've created it. And in fact, if I keep it in there, it's going to cause a problem. So I've dropped the split variable in the training set and the test set. Okay, so now we've got our training set, we've got our test set. The final thing that I need to do, and this actually won't be a factor on our homework, it's just a factor in this data set because there's a lot more independent variables. Okay, so like I said, this neural network package, it's a little bit finicky about how you type your formulas in. Okay, so if you just wanted to run a very simple formula, like if you wanted to use price as your dependent variable, and so let's say that you wanted to use the number of bedrooms and age and something else. Let's say you wanted to use what other variables are in this thing again? Let's say it's land value. Okay, so I could do land value. Okay, this will work absolutely no problem. Okay, if you're just manually typing in your independent variables, it works exactly like before. The only thing it can't do is it can't do this. Okay, remember that previously you can do, you can just insert a period if you want the computer to basically use all of the other variables other than the dependent variable as independent variables in your model. Okay, but unfortunately, this notation does not work for the neural net package. You can't do that. Okay, and so if you want to do that, okay, what you can do is you can use this shortcut I have up here. This line of code will basically return a formula that has all of the independent variables besides whatever you're using as your dependent variable. Okay, so you can see if I run this command, okay, and then I evaluate the thing that I created, my formula, okay, you can see that it returns a formula containing all of our independent variables, and that contains price as our dependent variable. If you were doing this on another data set, you would just need to change the name of the dependent variable to whatever you wanted it to be, okay, and just run this line of code as before, and it'll work, okay? And so then down here, instead of putting in this big long formula, okay, I could just simply put in here my formula, okay, and my formula is this formula that I have up here. Okay, so let's do it. Okay, let's just train up this neural network. We did this last time, but we'll just do it again. Okay, and in fact, let me just run all of my code starting from the beginning. Okay, just to make sure everything's up to date. You can see up here it's still training it. Okay, it's training, it's training, it's training. It takes a little while to train up. Okay, there it goes. Now it's done. Okay, now I can plot this neural network if I want to see what it is. Okay, and I'm just going to get the same. Here, one sec. It's like for some reason it's spitting it out in like a different window. Let me show you guys that window here. There it is. Okay, so here's a picture of that neural network we just trained up. Okay, and then once we have this neural network, okay, model trained up, we can use it to make predictions using the exact same code that we did before. Okay, so that is to say, suppose we want to use this to make some predictions for our training set. Okay, this is just the exact same code we've been using all along to make predictions. So I'm going to create this price underscore predicted variable. I'm going to call the predict function on our network, on our artificial neural network that we just trained, and the new data that I wanted to use, the data that I wanted to base the predictions on, is simply going to be the training set. Okay, run this code, you're going to get a bunch of predictions. Okay, let's have a look at those predictions. Okay, you can see here's my price. Okay, notice it's still scaled. And then here's my predicted price. Okay, and that predicted price is also going to be scaled, okay, according to the same sort of rules. Everything's going to be between 0 and 1. Okay, so here's my predicted price. Okay, now it's kind of frustrating staring at that scaled value of the variables. Okay, it'd be kind of nice if we could convert these predicted prices back to their original values so we can sort of get a sense of, what they actually are, okay? And what I have here is that these two lines of code here, okay, are simply going to convert those prices back to their original values, okay, back to their unscaled values. It's going to scale them back up, okay? So you can see, and again, you don't have to write this bit yourself. You just have to, reuse my code, okay? Basically, how this command works is whatever variable you're trying to scale back up, okay? In this case, it's the price. You just want to, have that in here. You can see I have the price. If you wanted to scale up some other variable, if it was, another variable going by a different name, every time you see price in here, you would just replace that with whatever variable you wanted to scale back up. Same thing here with the price predicted. Okay, you would use you would use the price predicted here. Okay, and then so here for the maxes and mins, you would use the price. You would still use the price. Okay, because our original maxes and mins value. Okay, these maxes and mins that I evaluated before, maxes and mins. Okay, they don't have the price predicted variable because we only just created the price predicted variable, okay? But you want to scale up this price predicted variable using the mins and maxes associated with the original price variable, okay? So here I'm scaling up price back up based on the maximum and minimum price, and then I'm scaling the price predicted back up again based on the maximum and minimum price. So if I run these two lines here, okay, go back to my training set, you can see now that this price is back to its original value, and then this predicted price has also been scaled up back to these real price values. Okay, and so from this point forward, I could evaluate the accuracy of this neural network. I could compare the accuracy of this neural network to some other model. I could tweak the hyperparameters and see if the accuracy improves. Everything from this point is exactly the same as before. Okay, so I hope all of that makes sense. Okay, and in the final video, I'm just going to briefly go over what I want you to do for your assignment.